Starting from version 3.0, TDengine has become a cloud-native time series database. In this video, we will introduce the distributed architecture of TDengine 3.0. Let's take a look at the logical architecture of TDengine. A complete TDengine system runs on one or more physical nodes. Logically, it includes data node, D node, TDengine client driver, TOS-C, and application. There are one or more data nodes in the system, which form a cluster. The application interacts with the TDengine cluster through the TOS-C API. Physical node. A P node is a computer that runs independently and has its own computing, storage, and network capabilities. It can be a physical machine, virtual machine, or Docker container installed with OS. The physical node is identified by its configured FQDN. TDengine uses FQDN for network communication. Data node. A D node is a running instance of the TDengine server-side execution code TOS-D on a physical node. A working system must have at least one data node. Each D node in the system is uniquely identified by its endpoint. The EP is a combination of the FQDN of the physical node where the D node is located and the network port number configured by the system. By configuring different ports, a P node can run multiple instances or have multiple data nodes. Virtual node. To better support data sharding, load balancing, and prevent data from overheating or skewing, data nodes are virtualized into multiple virtual nodes. The V node is the basic unit of time series data storage and has independent running threads, memory space, and persistent storage. Each V node contains a limited number of tables, all belonging to the same database. However, each database can be split among multiple V nodes. The M node in the cluster automatically creates new V nodes as necessary to store the tables in your databases. In addition to time series data, a V node also stores the schema and tag values of the included tables. A V node is uniquely identified in the system by the EP of the data node and the V group ID to which it belongs, and it's created and managed by the management node. Management node. The management node is a virtual logical unit responsible for monitoring and maintaining the running status of all data nodes and performing load balancing among nodes. The M node also stores and manages metadata, including users, databases, tables, and static text. You can configure up to 3 M nodes in a TDengine cluster, and the system automatically creates the nodes and forms them into a virtual management node group. The leader-follower mechanism is adopted for the M node group, and the data synchronization is carried out in a strongly consistent way. Computation node. A virtual logical unit responsible for executing query and computing tasks, including the show commands based on system built-in tables. There can be multiple Q nodes configured in a TDengine cluster to share the query and computing tasks. A Q node is not coupled with a specific database. That means each Q node can execute the query tasks for multiple databases in parallel. There can be at most one Q node in a single D node, and the Q node is identified by the EP of the D node. TDengine client driver can get the list of Q nodes through the communication with M node. If there is no Q node available in the system, query and computing tasks are executed by V nodes. When a query task is executed, according to the execution plan, one or more Q nodes may be scheduled by the scheduler to execute the task. Q node can get data from V node and send the execution result to other Q nodes for further processing. With introducing Q nodes, TDengine achieves the separation between storage and computing. Stream processing node. A virtual logical unit responsible for stream processing tasks is introduced in TDengine. There can be multiple S nodes configured in a TDengine cluster to share the burden of stream processing tasks. S node is not coupled with a specific stream. That means a single S node can execute the tasks of multiple streams. There can be at most one S node in a single D node. is identified by the EP of the D node. M node schedules available S nodes to perform the stream processing tasks. If there's no S node available in the system, stream processing tasks are executed in V nodes. Virtual node group. V nodes on different data nodes can form a virtual node group to ensure the high availability of the system. The virtual node group is managed using a leader-follower mechanism. Write operations are performed only on the leader V node, and then replicated to follower V nodes, thus ensuring that one single replica of data is copied on multiple physical nodes. The number of virtual nodes in a V group equals the number of data replicas. Virtual nodes group are created and managed by the management node. And the management node assigns them a system unique identifier called the V group ID. If two virtual nodes have the same V group ID, it means that they belong to the same group and the data is backed up to each other. TDC. TDC is the driver provided by TDengine to applications. It is responsible for dealing with the interaction between application and cluster, and provides a native interface for the C and C++ languages. It is also embedded in the JDBC, C#, Python, Go, Node.js language connection libraries. Applications interact with the whole cluster through TDC instead of directly connecting to data nodes in the cluster. Okay, so we learned the different logical units in TDengine, which is the basis for a deeper understanding of the core TDengine architecture. If you'd like to know more about TDengine, you are welcome to download the source code from our GitHub repo and take a look for yourself. See you in the next video. Bye!